Last session of this Basecamp 8, and this is all about Cairo smart contracts. So as a review, session 1, we covered fundamentals, a little bit about architecture. Session 2, deep dive, we actually went deeper into the architecture, some of the features of a Starknet. Session 3, we actually learned about vanilla Cairo, in this case, just using Cairo on its own, not even on the blockchain, not even on Starknet. And we did that by solving Starklinks. And then today is Cairo smart contracts. Topics for today, I'm going to talk a bit about what are the requirements for graduation and how am I defining who's actually getting the title to be a Basecamp graduate. We're going to then do some live coding, solving this counter workshop. And we're going to deploy it then to testnet using a CLI. Then that's optional. If we have enough time, we're going to also solve, or at least start solving, another workshop of the ownable workshop, which is about reusable components. About the homework, you know that the homework is to solve Starklinks. The only thing pending was the Starknet exercises, right? Because that's connected to today's session. So just remember that that's going to be the homework for today, just to finish a Starlink, to finish the Starknet exercises from Starlinks. Remember that when you finish completing this tutorial or interactive tutorial, just publish it on a public repo on GitHub, and then register that repo on this link here, which is a Google form, just so I can go there and check that you actually completed, because that's part of the graduation requirements. And you're going to have until next Friday, February 9th, to do the submission, and you complete the whole of the Starlinks, which is your homework. Then I'll post on Discord on the Basecamp channel the instructions to claim the Basecamp SPOC, which is a POAP. So make sure to you join the Starknet Discord so you get notified and you will know which link to use to claim it. Now, graduation, let's say there's 3 levels of graduation. Let's say people who, let's say, attended at least 25% of the classes, but let's say they didn't participate in any of the quizzes, tests, or submitted any homework, you will have a SPOC for attendee. You're a Basecamp attendee, right? You're not technically a graduate, but you participated. Then we have another SPOC or a POAP for people who actually graduate, and those are people who attended at least 50% of the live classes, able to take attendance, and that score at least half of the total points in the course. And I'm going to tell you later how these points are calculated. But then I have a special POAP or SPOC for people who did actually really good during the course, people who attended at least, again, half the classes live, but also score 80% or more of the total points to be awarded during the course. Now, the way that points are being awarded is that quizzes, we had 3 quizzes, 1 in session 1, 2 in session 2, and each one of them had 5 questions. So it's going to be 1 point per question for a total of 15 points in quizzes that you can get. Then tests, actually, because they're more complex, I'm awarded 2 points per question, and we have 2 tests and of 10 questions each. So that's a total of 40 points that you can obtain. And then by solving the Starlinks, so being the homework, that's an extra 20 points. But of course, it only applies if Starlinks actually is running. If I run it, it actually passes all the tests saying that you actually completed Starlinks. But of course, we have some bonus, because I know some people were not able to join live at the beginning. Maybe if you did well in the quizzes or tests, here's a chance to get extra points to catch up. So the bonus activities is actually to go to Node Guardians and complete some Cairo quests. So let me open Node Guardians so you know what I'm seeing. So this is Node Guardians. It's a very cool platform to actually learn Cairo, Solidity, and it's kind of like gamified. So you earn points, you actually have a character, and you buy some like loot for the character based on quests that you solve. Let me see. If I go to quests, campaigns, I can filter by Cairo. You can see that there's 3 quests here, right? So they have different levels of difficulty. So you can take any of the 3, and they have different points. And these are bonus points, right? So if you solve the setting up Cairo, which is the easiest one, you get 10 extra points. If you solve thinking in Cairo, you get 15. You solve bad accounts, you get 40 extra points, right? Again, you don't have to submit any proof in this case, as in the case of the homework, because I actually can talk to Node Guardians. They gave me a list. I actually have your GitHub username, so I can just correlate that. So I will know who did what, and the deadline is the same, next Friday. So that's your chance to earn extra points and hopefully get the cum laude spot for excellence during Basecamp. And let me share with you the link to Node Guardians, the chat, and on YouTube. All right. So that's it. So now we can actually go and start coding. There's a question from Jordan. Regarding the Starlinks completion, because I cloned the repo originally from Starlinks when I included the solutions and post to my public repo, the build fails because there is a test to see if all exercises require confirmation and I am not done. This isn't a problem for you review, right? So does it mean that you didn't remove the I am not done comment on the exercises? So you did remove them, and when what happens? It doesn't run? The internal test failed for the build. Okay, I can take a look, but I mean, if you completed the test, that's the important thing. So going back to the workshop that we're gonna solve today, we're gonna solve this counter workshop. So let me open it. All right, so this is the workshop we're gonna be doing today. I'm gonna put the link here so you can go and take a look at it. Let me increase the font size. So this is the Starknet counter workshop. So it says, in this workshop, you learn how to create a simple Starknet smart contract, implement public functions, events, and extra external contract. After completing each step, run the associated script to verify it has been implemented correctly, and use the Cairo book and the Starknet docs as a reference. Okay, so first step will be to clone this repo. Do all of you have actually Scarp and ASDF installed in your computers? Does any of you don't have it? Should I go through the installation of Scarp and ASDF? Maybe I should do it because I don't see many people reacting and I want you to code along with me. So I'm gonna start by, I'm gonna follow here the instructions. I'm just gonna clone this repo first. So I'm gonna open my terminal. Let me put it here. Let's see, how do I do this? To show you all from scratch, maybe I should use the VM. So we start from this very beginning. Let me open the workshop here. So GitHub, Starknet.edu. And we're doing the counter workshop. All right, so I'm gonna start by cloning this repository list and put git clone. So I can get into the file, to the folder, counter, workshop, and I can open VS Code in this folder location. All right, let's continue with the instructions. So we have cloned the repo. What's the next step? Now it says, create a new file called counter.cairo inside the source folder. And we're gonna copy this static code in there, right? So I'm just gonna copy this, go into my Visual Studio Code. So I'm gonna go to my source folder and I'm gonna create a new file called counter.cairo. And I'm gonna paste the code that we just copied. Now, we have an issue because obviously we don't have any syntax highlighting here working, which makes me think that we might not have the Cairo extension. So let's go to search the extension and we need to get the Cairo 1 extension. Okay, install it in VS Code. Don't install just the Cairo, is the Cairo 1.0, the one that we need. I can see that there's some issue that you couldn't start the Cairo language server, and that is because we don't have Scarp, so the extension doesn't know where to find the binary, right? If I do Scarp version, there's nothing here yet, right? So we need to continue doing the instructions. So in the note says, you'll be working on the counter.cairo file to complete the requirements of each step. The file prefsolution.cairo will show up in future steps as a way to catch up with the workshop if you fall behind. Don't modify that file. So obviously it's not here yet, but in this workshop, we're actually gonna be changing branches as we move along. And you're gonna see a new file coming up in this folder called prefsolution, which basically has a solution to the previous step. So if you get stuck, you can take that code, put it in the counter.cairo code contract, and continue from there. But then we have the installation. So the next set of steps will depend on whether you prefer using Docker to manage global dependencies or not. So we have two options. One is without using Docker, and one is with Docker. Right now, I'm gonna show you the one without Docker, which is installing manually. First of all, ASDF, then installing the Scarp, then Starknet Foundry. And then I'm gonna go back to my host computer, my Mac, and I show you with Docker, if that's your preference. So first step will be to install Scarp, and it's always good to do it through ASDF. So installing through ASDF, it's we need to install ASDF, right? So let's search for it. ASDF install. Okay, so ASDF, how to install it? Font size increase. So we have here, these are the instructions, right? So we can copy this command and paste it in our terminal. Could be also in VS Code, doesn't matter where. Actually, yeah, it's the same. Let's go, and that installed, in theory, ASDF. Probably I will have to restart the terminal. Let me close it and open a new terminal. Yeah, we need to do an extra step. So to install it, or at least so the binary is available for us, there are multiple ways. You need to find the combination that makes sense to you. If you have bash and git, or bash and git in Mac OS. In my case, I actually have CSH and git, right? CSH is my shell. So you can add this line to your configuration file, CSHRC, or you can add the ASDF plugin. So let's open this file. How do you know which go to choose? I think you can do echo shell. It will tell you which shell do you have. In my case, I have CSH. That's the one that is active. Maybe yours might be bash. But in my case, I have to open this file. So I go code. I have to go to my home folder, HRC, open this file, and this is where my configuration is. So if you're using my C shell, so you have two options, right? But they tell you here that you can either copy this line and you paste it at the very, like the last line, you can put it here. That's one way. Well, my preferred way, just because I have all my C shell active, is to actually add it here as a plugin. That's only if you have all my C shell. Otherwise, you have to add the line at the end of your configuration file. Let me close everything for a moment, use the terminal, and reopen it so I make sure that it gets all the changes. So now if I do ASDF version, now the binary is actually, so that's first step, having ASDF in your terminal working. So next step, let me go back to Scarp. So now that we have ASDF, we actually can use it to install Scarp as a plugin. ASDF is a package manager. I see it as maybe as a replacement, as a lightweight version of Docker, where you can actually manage global dependencies with that. I actually quite like it. So now we're gonna run this command. I'm gonna copy it. I'm gonna paste it here. Copy, paste. ASDF plugin add Scarp. All right. So we have Scarp. Good. Let me go back to Starknet edu. To the workshops, because we need to install a Scarp 2.5.1 and also Foundry. So I'm gonna add also the plugin for Starknet. Let me clear the screen. ASDF plugin add Starknet Foundry. This is for the tests. So since we're working, we have now the two plugins. That's good. Let me go back to the counter workshop. So here, if I reopen, if I list all the items, you can see that we have a file called tool-versions, which defines which version do we need actually from Scarp and from Starknet Foundry. So if I actually show it to you, the content, you see that it's asking for Starknet Foundry 0.16 and Scarp 2.5.1, right? The one that we need. So I think you only need to do ASDF install, and it's gonna go and download these versions defined by the tool versions file. That's neat. So now if I do Scarp version, you see that I have the right version of the Scarp installed. If I do Scarp SNForge, sorry, SNForge is one of the binaries from Starknet Foundry. It's installed. If I do SNCast, which is the command line from Foundry as well, it is installed. So we have the 3 global dependencies installed through ASDF, and those are defined by the tool versions file. So if I open again my VS Code, we should get syntax highlighting at some point. Let's see. Yes, right? So at least we know that the extension is able to find the right discarded binary and the right Cairo compiler binary. So it's all thanks to ASDF and this file. Because with this, we just completed these steps here. I'm gonna move now to my Mac. So I'm gonna stop the virtual machine because now I want to show you actually the Docker part. And I don't think I have Docker here. Okay, rebuild and reopening container. So with this command, what's gonna happen is that first of all, you will need to have an extension called dev container, this one, in your VS Code. So if you have it, you can actually reopen VS Code inside the container. So it will have all the binaries that you need, because all these binaries are going to be defined in this Docker file. This is only for people who like to use Docker. Otherwise, just stick with ASDF. I want to show you how it works. Rebuild and reopening container. That's the one. Okay. Yeah. This is because I'm the virtual machine in parallel. So let me do it in my post machine. Will be easier to show you. So let me go back to my Mac. I'm gonna clone. Let me open this. Let me just go back to master. Let me open here. This is my VS Code. So I should be able to, this is the final version of the code, but that's okay. What I want to show you is that I should be able to launch the dev container, reopening container. So that should be pick up this dev container file with a Docker file there as well, relaunch VS Code inside the container. And once it's done, you can see that now I'm actually inside the container, right? And in the container, I actually should have all the dependencies that we need as well, right? So that's the 2 ways, either using Docker or just installing dependencies directly with ASDF. All right, let me go back to the vanilla counter contract because here I actually went ahead. I'm just gonna close now my virtual machine to avoid confusion. Just gonna continue on my Mac. And I have here, right, back to the starting code in the counter card. All good. So let's see the next step. So we completed, I showed you both options. So now I can actually go to step 1. So it says, check out the step 1 branch to enable the verification test for this section. So I'm gonna copy this code. Should remove this symbol there, could be confusing. So let me go to step 1. My scope.toml was modified. Sorry, this is just because I was modifying this before. Git checkout. Step 1. Right? So when you check out to step 1, you should be able to see now this file, the previous solution, which basically is what we did before, just fine. So now what they're asking us to do is that in this step, you will need to do the following. Store a variable named counter as a U32 type in the storage struct. Then you will have to implement the constructor function that initializes the counter variable with a given input value. Finally, implement a public function named getCounter, which returns the value of the counter variable. So a new value in the storage, we pass it as in the constructor initial value, and we define a function to expose it to the world. So let's start with the variable in the storage. So we have the storage here. We define a new variable called counter, and we define the type to be U32. Now they're asking us to define a constructor that is going to get the initial value of that counter variable that is going to be set when we deploy this smart contract. So we define the constructor, which is a function called constructor as well. And this function expects as the first argument the storage of the smart contract, a reference to the storage itself, contract state. The type is always contract state for the first argument of any function of your smart contract. This is how the state, this storage is actually passed to all the functions to either read from it or modify to write to it. And the other variable that we need to, or argument that we need to capture is the initial value of the counter. So let's call it init counter, and the type will be the same, U32. So now I'm gonna assign this initial value to the storage. So I'm gonna do self, I'm gonna access the counter variable, and then the write method. And I pass the init counter argument that we collected there. So when we deploy, we pass this value, we store it inside the smart contract in this variable. So now we need to find a way to expose it to the world so anyone can call a function and see what is the current value of the counter. So we need to first define an interface for this contract. So let's call it, it's going to be a trade. Let's call it the I counter. It's usually the standard is to have the same name as the smart contract, just prefix it with an I for interface. And this trade is a generic. If you did the Starknet, you probably saw generics at some point. And this trade needs to have an attribute called the Starknet interface. So it knows that it's actually the interface of a smart contract. And the function that we want to define is get counter, right? So this get counter is going to get as the first argument. You can either get a reference to T, the contract state, the generic, or you can get a snapshot. The difference is that if your function is meant to be read-only, it's not going to modify the state, then you go for a snapshot. If your function is meant to modify the state, like use the write method, for example, then you go for the reference. So here, this one is just a read-only. And of course, it's going to return the current value of the counter, so which is that type, U32. Is it a semicolon? Is it a comma? What is it? So now that we have the interface, we can actually implement it here. Let me close the terminal for a moment. So I forgot how it was. ABI, bed, V0. Yes, all right. And I define impl. So I need to create an implementation. We're gonna call it the counter impl of the I counter trait. But to make this trait visible within this module, this counter, I need to first bring it into scope, a counter. So now I can find it here. I need to provide what is the generic, and the generic is going to be the contract state. It's always the same type, contract state. And now I have to implement actually the get counter function. Function get counter self of type is a snapshot of the contract state that returns U32. And what it does, it's simply reading the counter variable from the storage and return it. So we don't put the semicolon just to return the value, right? So this should complete the step one. So let's see. Nestor is asking, is there any reason to use the more abstract T type and not the T contract state type, just flavor-like? Yeah, doesn't matter the name. I could have called it. You usually see it like this in the docs, but it doesn't matter the name. Al final, it's just a generic. So I just like to call it T, more concise. The name actually matters is here, right? Because you have to define which type in particular you actually want to replace the generic with. So if this actually is correct, we should be able to run the test for this section and should pass with scarp test. And it passed. So we actually completed the step. Questions? I did this myself, but the next one I'm actually going to stop and just give the chance for you guys to do it. Folk is asking, is the generic, if the generic is always of the type contract state, why do we use a generic? It's a good point. It's just because this is the let's say, I guess the language could introduce some magic to make it more straightforward, like a more concise the way to do it. But remember that Cairo is meant to be used even outside of smart contracts, right? If you put too much magic into it, it starts to separate the Cairo that you use for a smart contract from the Cairo that you use for general purpose programming. This way is just a regular generic that you actually just pass the state of the smart contract. But when you use it in a regular vanilla Cairo smart contract, or sorry, vanilla Cairo program, you might actually pass a different generic. It's just a way to make it usable in different scenarios. All right, so we go to the step. By the way, each step has hints, right? So this step, you're gonna do the step. I'm just gonna wait, and then a little later I'll do it myself. So step 2. So check out the step 2 branch to enable the verification test for this section. So let's go to step 2. Nestor, I've been curious about naming conventions in Cairo because the I for traits is not recommended for Rust, like I counter. You mean like this? Yeah, it is strange just because talking about interfaces when you actually have a trait, but yeah, I guess it's your choice, right? You don't have to prefix with an I if you don't like it. The thing is, the tests is actually expecting that to be called, it's expecting that to be prefixed with an I, otherwise the test will fail. But in your own code, you can just call it any way you want. My test fail originally. Many outputs. A lot of them are about negative impulse are not enabled in the current crate. Anyone else get this? Jordan, do you have this version of Scarp? 2.5.1. Oh, failed before about the counter.cairo. Okay, so now that you have the file, actually, it works. Let me know if you're stuck. Anyway, for now, I'm just gonna go to step 2. Check out step 2. Check. Yeah. So the goal of this section is to implement a function called the increase counter that increment the current value of the counter by 1 each time it's invoked. So when you complete this goal, you should be able to run the Scarp test and it will pass. And there's a hint. The increase counter function should be able to modify the state of the contract, also called an external function, and update the counter value within the storage. You can read more about it in this chapter of the book, External Functions. All right, let me start solving the exercise now. All right, so we need to implement this function, the increase counter. So that function, first of all, we need to add it to the trait, to the interface. Now the question, should it be a snapshot of the generic or should it be a reference? And because increase counter is actually going to modify the value of counter, it needs to be a reference of the generic that at the end is just going to be the state. And it's not going to return anything. Right? It just modifies the state and that's it. So now we actually implement this function here, is counter, and the type is a reference of contract state. Now we define the actual type, not the generic, and the implementation. Oh, and it's gonna get passed. Oh, okay, I'm missing nothing. Nothing get passed, and it just increased. So I'm just gonna first of all collect the current value, collect current counter, check it from reading from the storage, and then I actually go and let's do it. New value, new counter, current counter plus 1. And now I save it again back to storage. So counter, write, and new counter. You can make it even smaller, just putting this code here directly, for example, but I like it to be more readable. So I think that's all we need to do for this step. So, so if that's okay, we should be able to run the test. Okay, good. It passed. Perfect. We can now go to step 3. So step 3. In this step, you will need to do the following. Import the kill switch contract interface into your project. Store a variable named kill switch as type iKillSwitch dispatcher in the storage. Update the constructor of the function to receive an additional input variable with the type contract address. Update the constructor function to initialize kill switch variable with the newly added input variable. Note that you need to use the iKillSwitch dispatcher with the expected contract address as its type. So the idea here is that we need to prevent the increased counter from working if an external smart contract actually returns false. If it returns true, then we actually can go ahead and increase the counter. I believe that's what it's trying to do. Import store available, the construction permission. No. So far, just trying to collect the address of the kill switch. So it's going to be an external smart contract that we're going to be using inside the counter to interact with it. So first step, actually, I'm going to wait here a few minutes for you guys to give it a go. And then I'll go ahead and solve it. If you look at the scarp.toml, you're going to see that there's a dependency called kill switch that is actually pointing to this repo. Let me start completing this step. So let's take a look. Okay. So we want to be able to call this kill switch contract at some point in the future. And to be able to call a contract, we need to have their dispatcher. Let's take a look at the Cairo book for a moment. And we can take a look at ABIs and interfaces. So this is the page that I'm looking at. So here you can see how to call it contract dispatchers. Just try to look for an example code. Here's one. So to call another contract, we need to use the dispatcher of its interface. So when we have this interface here defined, this macro actually generates some code. And what it does, it generates code for a dispatcher to interact with the trait, with the interface. By importing the kill switch, we're gonna also get the dispatcher of that smart contract or that interface. Then we provide the address, and then we're able to actually call functions in the smart contract. So this is what we need to do, but for the kill switch, right? We need to find this dispatcher and we need to find the address. So let's see, we have to import the kill switch. So if I look at the Starknet toml, it should be available under the kill switch. And then let's see what's available. Here's the kill switch dispatcher. That seems to be what we're looking for. So the idea is that at some point in the construction, we're going to get the address of where this was deployed. So here, let's call it the kill switch address. And of course, the type of this is contract address, which we need to import as well, bring into scope, use Starknet, I believe is from here, contract address. So we have in theory, the address, the right type. Now we need to derive the dispatcher from it. So we do kill switch dispatcher, right? Similar as the book, when we pass the contract address. So contract address is actually the kill switch address, right? And we can collect this as a dispatcher, and then we can actually store it. So let's store it here under kill switch, and the type will be the kill switch dispatcher. And now we can actually save it. Counter right kill switch, and it's not working. Why? Because I call it dispatcher, right? It's not working. Why? Because I put counter instead of kill switch. Okay, seems to be fine so far. Let's see what else we're being asked here. So import the kill switch control interface. We did it. We store it in this variable kill switch in the storage with this type. Yes. We update the constructor with a function to receive the address of the smart contract, and we initialize. Yes, we actually store this type in this storage address of this type. Let's take a look. Let's try to run the test, see what happens. Yeah, it works. Okay, Nesra, could you explain one more time? Sure, no problem. So at some point, we want to interact with this smart contract, the kill switch smart contract, the one that I show you here, right? This smart contract is actually deployed. So the thing is, how do we call another smart contract from our smart contract? And the way to do it is by grabbing its dispatcher, okay? And the dispatcher is available to us because we define this smart contract, the kill switch, to be a dependency of a project. And if you look at the repo for the kill switch, you can see that it has an interface called iKillSwitch, annotated with this interface attribute. And this macro, what it does is that it generates automatically the iKillSwitch dispatcher, which is, let's say, the object that you can use to actually talk to it. So the only missing component to actually talk to the smart contract is to actually know where it was deployed, in which address, which is the thing that we need to provide when we actually deploy our counter smart contract. Does it make it a little more easier to understand? So once I get the dispatcher, I actually put it in the storage just for able to use it later more easily. Jordan is saying, there's no method in Script.toml to give the contract address for the kill switch dependency. Is the only purpose of this step 3 code to give programmatic access to contract address of kill switch, even though this contract has one change? Why not hard code it in the text file? Right, so if I understand your question is, basically, why do we have to pass the address here instead of just maybe have it somewhere in the Script.toml, like maybe somewhere here? I guess that's your question. And the reason is that you can deploy the exact same smart contract in multiple addresses. Remember that we declare the code, and the deployment can be a million of them. It could be a million copies, all of them using the exact same interface, but all of them have a different address. So why not put it here in the Script.toml? I guess it's possible potentially, but again, it will create some coupling between the tooling, the Script.toml, and the way that Starknet works. So that way you get more flexibility. You can actually use the same code and just, you deploy it, you just pass whatever instance of the kill switch you actually want to use. If you recall back in session, I think 1 or 2, we discussed about the difference between a class and an instance when it comes to smart contracts. So this is it. There, the instances are identified by its address. So we are now in, we're gonna have to go to step 4. You check out step 4. Okay, let's take a look at the requirement. So the goal here is to implement the kill switch mechanism in the increase counter by calling the isActive function from the kill switch contract, right? Remember, that's the only function that the kill switch has. Requirements. If the function is active from the kill switch contract returns true, then allow the increase counter to increment the value. If the function is active from the kill switch contract returns false, then return without incrementing the value. And hence, you can access the isActive function from your kill switch variable. Use this to create a logic in the increase counter function. So a few minutes for you guys to solve it, and then I'll solve it myself. Next is asking, what about names for contracts that are multiple words? Let's say I want to name a contract counter contract. Should I name the file like a Pascal case or a snake case? I'm asking because I see Rust style convention in the project. Yeah, that's a very good question that we keep debating. What is the right thing to do here? Yeah, so far the convention seems to be like for things like modules and interfaces to use Pascal case, but then for any function and variable to use a snake case. This is something that is just a convention. You can just follow your own convention. You can just put here a snake case if you want in the kill switch, for example. But that's a good question because in Rust, everything is a snake case as far as saying, everything is snake case, even like enums? I think that even in Rust, there's sometimes you use Pascal case. Let's see, Rust, Pascal case, snake. Right. So they say modules a snake case, which is actually different from what we're doing right now in Cairo, right? Because the smart contract is a module. But then for types, traits, and enums, they actually use Pascal case. Okay. So we actually bring a convention here. That's the only place. The rest we actually following more or less. But again, you can use your own convention. But that seems to be in the Starknet community, seems to be camel case for modules instead of snake case. That's the main difference with Rust. Hey, if you want to see this, maybe that's a good thing to add to the Cairo book. You can get some money by helping out. Just make sure to sign up to Only Dust first before you submit your fix or your new entry to the Cairo book. All right, has anyone completed step 4? Can you raise your hand or just let me in the chat? So we have to use that kill switch contract somewhere here in this function, the increase counter. And we're getting some failures in step 5. You're a little ahead. Okay, let me start solving this one. So the idea is that if the function is active from the kill switch returns true, then I'm allowed to increase the counter. If it doesn't return true, I don't increase the counter. So I'm gonna do it at the very beginning. First of all, I need to grab the dispatcher from the storage because the dispatcher is what I use to actually talk to the smart contract. In that dispatcher, let's bring it here. Dispatcher. Actually, just gonna call it kill switch. It's more specific. And it's gonna be equal to self kill switch. This is the storage variable. We read. Right. We have it here. So now I can do like kill switch. Now I can call the function is active. Look that I get autocomplete, which is nice. And I'm gonna use this instead of an if statement. Okay, so if this returns true, that is active, then I'm allowed to do all this increase. If not, nothing happens. This is something that I requested the author of the workshop to modify. It's a more common pattern that if you cannot do the action, you actually revert. You stop and revert the transaction with an assert. It is not what the test or the step is requiring, so I'm not going to do it now because it will fail the test. But just keep in mind that it will be more common to do like something like else and then some assertion and fails. Or just do assert here, sorry. Instead of the if statement, do the assert here. But anyway, I'm not going to do it now because it will fail the test. Carl is saying, actually, AI interaction with Cairo is so poor. That is why we need Cairomancer. Yeah, I'm trying to use ChatGPT to get some autocomplete with Cairo, and it's like it doesn't know. It seems to only know old Cairo, not new Cairo. I haven't tried Copilot yet. Let's try now run the test. Scarp test. Let me just clear the screen. Scarp test. Yeah, it works. Yeah, step 5. Let's take a look. So the goal here is to implement an event named counter increased, which emits the current value of the counter. Then we have to emit this event when the counter variable has been successfully incremented. And they gave us as a hint Events are custom data structures that are emitted by a contract. More information about events can be found in this chapter of the book. So they're showing here how to create events, and that is a good example of how events are actually created in a smart contract. You have a top-level enum called event that can have a multiple entrance, but each entrance is actually a struct of the same name. I believe they have to be the same name. And then you define those structs below with these attributes, right? And your event can have multiple, let's say, arguments, and you can define which one of them are keys to be indexed. And then when you want to use it, you call it like this: self.emit, the variant of the enum, and then the values of the arguments. Next story is asking, in Cairo, do we have a limit on the event fields locked like in Solidity? Actually, it's a good question. I don't know. What's the limit in Ethereum? Is there a limit in the events or in the keys? Like in event fields or in the keys? Oh, in the keys. Then you can only have like a maximum 3 keys, if I believe in Solidity. I don't know, but I'm gonna assume that it's the same limit because it doesn't make sense from a database perspective to have way too many keys. It's very inefficient, the indexing, but you can try multiple index to see what happens. But I'm willing to bet that it's a similar restriction. So August asks, if the kill switch had a write function, can I still use it in the same way? You can, but that's a good way to. It's a good question because let me go back to the counter contract. So the question is that, oh, I closed the kill switch. Anyway, if the kill switch had another function that actually modified the state, can I use it here? Well, in this case, you will be able to, yes, because this function is actually also modify the state. The thing that I'm not sure is that if this function were using like a read-only version, using a snapshot, I don't think you should be able to call a function that modify the state. But I haven't tried. But in theory, in this function in particular, yes, you should be able to call any function, either it's a read-only or write as well. The main difference is that functions that are read-only, like for example, get counter, you can actually interact with them using what is called just a call, right? Which you don't pay any gas. It's not a transaction. You're just reading the state, so it's for free. But anytime you interact with a function that actually modifies the state, like this one, you actually have to pay gas fees for the execution. Okay, let me start solving this. Step 5. So we need to create an event called counter increased. Okay, so if I look at the docs, I know that I have to create this enum call event. So I'm just going to copy this as a, yeah, and I'm just going to modify it. So I'm going to go here at the top. Where do I put it? Maybe. But now the events are different, right? It's going to call increased counter, and the struct needs to be of the same name. What's the name? Increased counter that is asking. I know counter increased. Oops. Counter increased. Okay. So now we define the struct from here. And what do we need in the event actually? Just to emit the current value. It's not even asking to provide the old value. So the only thing that requires counter, which is U32. In this case, it doesn't make sense to have the counter as a key. It's just a value, nothing that you want to be indexed. So this will be how do you define the event. This is the main enum where you can have multiple types of events in the same smart contract. But then for each one of them, you have to define, okay, what are the values and which ones are the keys? So now to use it, the idea is that when I increase the counter, I emit the value. So it will need to be inside this if clause. So here I can do self dot emit, and then I pass the, is that how it works? I mean, look at the book. I define the struct name and the values. Okay. So the struct name was counter increased, and it's expecting it's a struct, so it's expecting the counter property, which in this case will be new, right? That sounds about right. So we define the event, we define the event, define the const the struct with the value we want to define, and then we actually emit it if only we increase the counter. Let's see. Yes. Okay, that in theory, that's actually the end of the workshop. It only tells you to go to step 6, just you can see the previous solution. So let's just do that just for completeness to check out step 6. Logan is asking, in idea why I get a failure, there should be one key. it's asking you to actually have one key. That's so strange. Ibrahim, yes, I can see your message. So if that's the case, well, you can add a key, but doesn't really make a lot of sense. So you get that error running the key here. I had that error too, but then you remove the key. Oh, you have to remove the key. Okay, that makes sense. Yeah, this is how I define mine. No key attribute. Why in this case we don't use a key? Because for key, you want something that is meant to be unique, like an address. It's usually an address that you use as a key. Counter is actually a value because the key is used for indexing. This at the end, this goes to a database, it goes indexed. So you need to use your criteria to what things are supposed to be keys and what things are just values. What I want to show you now is how to actually take this smart contract and deploy it to testnet and then interact with it directly on Gherli in this case. So we actually have right now the CLI with each SN cast. You should have the same as well. So if you recall from previous sessions, in order to deploy a smart contract, we have to first declare it, then deploy it, and then we can actually invoke it. So let me open first the documentation for Starknet Foundry, because I'm gonna have to use a lot the book to guide me. So this is the docs I'm gonna be using. I'm gonna put it here in the chat. And I can go and take a look at cast. This is SN Forge, SN cast commands. All right. So because to declare and to deploy and to invoke, we have to pay for gas fees. And to pay for gas fees, we need to have a smart contract, sorry, a wallet associated or a smart wallet. So with cast, we can either create a completely new one that is managed by cast, or we can add one that we already have. In this case, like a Bravos wallet that you have, that you can just connect to Starknet Cast and use that to pay for gas fees. That is my preferred way, because that way you can actually keep track easier of how much money you have left. And it's nice just to be able to connect a regular wallet with your CLI. One thing to keep in mind is that right now, SNCast only supports smart wallets written in Cairo 0, not in Cairo 1 yet. That means that you cannot use Argent X at the moment, because Argent X actually using Cairo 1. You will have to use Bravos, because all the accounts in Bravos are actually right now Cairo 0. Eventually they will become Cairo 1, but for now it's Cairo 0. That's the one that is supported by SNCast. So you see that I have here an account called deployer on Gherli. So make sure that it's in Gherli. We don't want to deploy to mainnet. We want to pay real money. I got this little bit of ETH from the faucet. This is the faucet. So, okay, let me take a look at my docs. Okay. So if I take a look at the SNCast command for add, so import an account to accounts file. So actually we have to pass multiple arguments. We have to pass the URL of the RPC that we're going to use to interface with the sequencer. If you recall from the architecture discussion, you don't talk directly to the sequencer. You talk is to an RPC, and that RPC works in your behalf to actually talk to the sequencer. And sometimes the RPC directly gives you the answer you're looking for. So we need to create, have an URL for an RPC that we can use. And there are multiple ways to have it. You can use Infura, you can use Alchemy, you can use Blast, but I'm going to use this time Voyager. You can actually go to Voyager online, which is the block explorer, and you can create an account, right? I'm going to sign in with my credentials. So my email, it's free to create an account, and I'm going to create a new key, right? An API key to use the RPC. Philip is asking, what is the difference between SNCast and UCI? Those are two different tools. Both are CLIs for Starknet, so you can use either one. I think the benefit of Starknet is that it supports Cairo 1 or smart wallets between Cairo 1. It's just I don't want to go through the process of installing yet another dependency, because SNCast already come pre-installed with Starknet Foundry. That's the only reason that I'm using it right now. But Starknet is a really good choice as well. So make it a new key. Let's call it this Basecamp, because I'm going to remove it after we finish. And I get the key, continue. Let me open this. So, okay, so we want to use Gherli, right? And Juno is which particular, that is the client, the RPC client they actually use. So I'm gonna copy this. Let me, for now, I'm just gonna get a new file just called commands, just some place temporarily to write things down before I actually send the commands. So this will be the URL, but to use the API key, I actually have to pass like this, and then I paste the actual key. The API key is something that you don't share with anyone. I'm just gonna put it here and then delete it after we finish this workshop. So make sure you use your own API key. That will be the URL flag, right? If we go back to the SNcast, if we open this, it will be with this URL flag. So the command will be something like SNcast sound. So SNcast, I have here, this will be the URL. And then we actually, the command we're gonna execute will be count add, and we continue taking a look at the others. So we have to define the name of the account we're creating here and the address where it was deployed. Those are the two required properties. So let's go declare the name. I'm gonna call it Bravos, and then the address. I'm gonna go ahead and just copy. Remember that it has to be Bravos because it's a Cairo 0 account that is currently supported, and it has to be an address on Girly, not on mainnet. Just make sure that you have this set up to Girly. Okay, I think that's all. So the URL, the name, the address, and I think I'm missing something else. Oh, okay, right. We need to provide a private key of that particular account. So I'm just showing this because this is a throwaway thing that only has 9 test ETH or 9 test dollar. But the way to show it here will be, if I remember, show private key. Copy. Again, I don't mind showing this because this is just doesn't have anything. So I go back to my command. It's gonna be the private key. It's there. Let's see what else do we need. And let's add profile. So this will create an entry inside the scar.toml. Let's give it a try. I'm gonna copy this whole command. Let's put it here. Hey, whole thing failed. Isn't class require subcommand of one was not provided. Why? Oh wait, I'm missing all the backspaces. So it's a multi-line command. Try again. All right, this time it worked. So if I go to scarf.toml, you can see that there's wait, anything added? Yes, we have this new entry. Tools with sncat.bravos that defines the account, where it's been stored, and the URL of the RPC server. So that way, next time we use SNcast, we don't have to provide all those values by hand to make it a little shorter. And so next step is actually now let's declare the smart contract. So make sure that you build it. The project should be built already, but just in case. So now we actually go to the declare. So let's take a look at the declare here, right? So for this command, we need to know the contract name as defined in the contract file, and then that's it. Okay, so that will be sncast declare. We do need to provide the profile, right? Which one do we have to use? We have to use this one, Bravos. So normally you will have to do something like this, P, and then you define which profile within the scarf.toml to use. But an even better way is that if you remove this part here, it becomes the default wallet. So I can just get rid of that part of the command, just do send declare. And it needed the name of the contract, which is just counter. Wait, I missed something. I need to pass the flag contract name. So -C. There is no contract at the specified address. Lowercase? No, this will be uppercase. Yeah, let me take a look. What am I doing wrong here? What am I There's no contract at the specified address. Async cast, declare. What if I use the full name? Contract name. It's not gonna work. That I haven't seen this error. Is anyone getting the same issue? Counter is called, yeah, that's the name. This is the issue of the live coding. Seen the activity, no activity yet. Wait, I wonder if that's not deployed yet. It's just deployed. Take a look at the Voyager one more time. I wonder if my wallet's been deployed actually. There's nothing here. Yeah, girly. Yeah, I don't think this is deployed. So what I'm gonna do, maybe they actually doing the same as deposit. No. Send 002 1. Oh yeah. Now it's deploying the account. No wonder why it's not working. Remember a smart wallet needs to have the UI and also the account contract deployed. That's the thing that we were missing. That's the error that we're looking at. So now that we did a transaction, it actually went through and also deployed the account contract and should be available now. Yes, accepted on L2. All right, let's try again just to see. Okay, now it worked. We have a transaction hash and then we have the class hash. Remember that when we declare, we actually get a class hash. And from the class hash, we can actually deploy instances using the universal deployer. So that is the next step. So if we take a look at the docs again to deploy, what it needs is the class hash and nothing else, which is the flag G. Okay. So I can do sncast deploy -G. Oh, I think I need something else as well. Pretty sure. Because it's going to need the constructor call data, right? Which basically we need to pass the initial value for the counter and the address of the kill switch. So let's go. I'm going to copy this again to my commands to deploy. This is the class hash. Now we pass, what is the name? The constructor call data. So the first value is the initial value of the counter. Let's say initialized with 1. And now we need the address of the kill switch where it was deployed in testnet. And I believe that is in the exercise here somewhere. Yeah, this is the address where it was deployed. So I'm gonna put it here. This is the second parameter of the constructor. That should be it. Let's try. Put the backslash. Let's try running this. And yes, it was deployed. It is deployed now to this address. So if we go to Voyager again and paste it here, we can see our smart contract being deployed. That it takes some time to index the smart contract correctly. That's why it's not showing here yet. But we can actually interact with it with the CLI as well. So I mentioned that you can actually interact with the read-only functions like get counter using a call, which is free. You don't pay gas fees. So let's do this first. Let's try to interact with get counter and get the current value. So that will be call. Here we need to specify the address where it was deployed, our counter smart contract, which function we want to call, the get counter, and the arguments, if there's any, which in your case, there's no arguments to be passed to the function. All right, so sncast call, and we pass the address, which, oh, I almost lost it here. Address, and then we have to pass the function name, which is the get counter. And I think that's it. All right. And we get the value 1. That is the value that we pass as to initialize the counter. So it is working correctly. Next step will be to increase this counter. Now we need to use an invoke transaction, and we actually have to pay gas fees for it. So let's take a look at the invoke. Those some of the things that I have open here. I don't need this. That's still processing. Okay, now it's actually showing you. Here's the increase counter for and read for get counter. If we query, we get the same value. So to do the invoke, we again need the same, the contract address, again, the function. Now we're gonna have call data. No, we're not gonna have call data either in this case because our function actually doesn't expect anything to be passed. So it will be async cast pretty much the same. Just instead of get counter, we're gonna call the increase counter. And instead of being call, it will be invoke. The transaction went through. So if this actually worked, if we call again the same, the get counter, we should now get 0x2. So let's check that this transaction actually is finalized before we attempt to continue. We duplicate. Yes, accepted on L2. This is the L2 finality. So if I just repeat async cast, get counter, now we get 2. So that completes how to use async cast to declare, deploy, call, and invoke. In this case, remember that async cast only works with accounts that are Cairo 0. That's why I can only import Bravos into this example. I couldn't import Argent X. But if you really want to use a Cairo 1 wallet, you can use a Starknet, which is another project, another CLI, Starknet, that I believe it does support Cairo 1 as well. So this is another CLI. It's similar to Cast, maybe even more powerful, has more options, but it works a little bit differently. All right, we made it to the end of Basecamp. I'm glad that we have all of you here, 26 people. So we didn't have time, obviously, to do the other workshop, but you can do it on your own if you want to. It's not going to be part of the homework. This is only if you want to keep pushing yourself. We have this ownable workshop in a very similar format with the steps. We also have the Docker. And if you want to get into account abstraction, we have this other workshop. So there's 3 workshops, 2 more that you can do on your own. Again, they're not homework, just do it if you want to. And remember to use do Node Guardians quest if you want to get extra points. Until February 9, I accept submissions for homework and extra points for Node Guardians. After that, I'm just gonna calculate how many points you will get. And then on Discord, I'm gonna share the link for you to go and claim your POAP. Thank you very much. I hope you enjoy it. And oh yeah, time for questions. Nestor, how can we get the events with async cast? I don't see a command. It's a good point. That's a good point. I've never tried to actually get events from CLI. I wonder if the Starknet has something like that. No, it's a good point. I don't recall even seeing that. But if you find it on the Starknet, please do let me know. Could be on Discord. All right. Bye-bye. Take care, guys.